This is the diagram of serial in, serial out shift register. Okay. To be frank, it's serial in, serial out, shift right, shift register because the data is going to be shifted right. Okay. And how does it work? Okay. Yeah, I have already written 4 bit serial in, serial out, shift right, shift register. Okay. This type of shift register accepts data serially. I have already shown in the previous video. That is 1 bit at a time. Okay, and also outputs data serially. Okay, and here we have written with 4 stages, that is 4 flip-flops. The register can store up to 4 bits of data. As I have told, in the case of registers, a register can store only 1 bit of data at a time. Okay, but here I have already told you with 4 stages. It for the when we consider this example, we can say it's just 4 stages. We can have any number of stages. Okay, so any number of stages means that many number of flip-flops, and the corresponding each flip-flop will store 1 bit of information, okay, of data. With 4 stages, that is 4 flip-flops, the register can store up to 4 bits of data. Okay, then when the serial data is transferred into a register, each new bit is clocked into the first flip-flop at the positive going edge of each clock pulse. Okay, and what is the specialty? Here, data or the input serial data is given to D1, that is, this is flip-flop 1, flip-flop 1, flip-flop 2, flip-flop 3 and flip-flop 4. Okay, serial data or serial input is given to first flip-flop, and the output of the first flip-flop is connected to the input of second flip-flop. 2 to 3, and 2 to 3 means output of the second flip-flop is connected to the third flip-flop. Output of the third flip-flop is connected to the input of the fourth flip-flop, and we get the serial output also. Okay, this is what you mean by what's the specialty of with 4 flip-flops, the register can store up to maximum 4 bits of data. Then when the serial data is transferred into the register, each new bit is clocked into the first flip-flop. For example, already, this is just an example, okay, already a data, say for example 1 is stored in it. Okay, when serial data is transferred into a register, each new bit is clocked into the first flip-flop at the positive going edge of each clock pulse. A clock is given and it's shown that it's positive going edge, there is no bubble. Okay, so what's next thing? Here a 1 is stored. The next input will be stored, that's serial in. We can't store it directly to flip-flop 2. Okay, next data will be 0. Okay, next data will be 0. For example, what we do is, during the positive going edge, this 1 will be shifted here and 0 will come into this place. Next clock pulse means, say for example, it's value 1 again. What do you mean during the positive clock pulse? What happens is, this will be shifted here. 0 becomes 1 means it will be shifted right, and 1 reaches here. Clear? Then say for example, another 1 is stored. Okay, what happens? This 1 moves here, this 0 comes here, this 1 is shifted right, and this 1 will be shifted to this position. Clear? And what happens in the next case? These are all shift registers, means also they are perform the operation of registers, but they have they have the capability of shifting the data. That's it. Okay, so what happens when the next 0 is stored? What happens? This will be shifted out. Okay, so 0 will come here, 1 will come here, this 1 will come here, and this 0 will be stored here. Clear? Shifting operation, shift right operation has taken place. Okay, so here I have constructed, this is just for the example, there is no need to draw these cases and all. I just showed this to, I have shown this to make this concept clear. Okay, so shifting operation has taken place. Here we have taken D flip-flops. Okay, so we can construct using JK, SR, any flip-flop. Okay, for the time being, please go through. This is 4 bit serial in, serial out, shift right, shift register. And now we will discuss the serial in serial out shift register, that is shift right shift register in this case, using JK and SR flip flop. You know, it's very easy. There is only a small change. In the case of D, we just gave one input, right, for D. But here what we do is the serial input is given, the positive is given to J1, that is first flip flop, that is J input of the first flip flop, and the negation part is given to K1. We have a Q1 bar part that is fed to J2 K2, that is FF2's inputs. Similarly, that to the output is fed to the third flip flop, then the fourth flip flop. Okay, and the clock is also given synchronously to all these cases. Clear? And same is the case with no change, just rearrange or change the alphabets. Okay, J1 K1, J2 K2, J3 K3, J4 K4 is replaced by S1 S1 R1, S2 R2, S3 R3, S4 R4, and also clock pulse is given. The positive is given to S1, and the negation part is given to R1. That's it. Okay, and in the figure that we discussed just previously, that is about the D flip flop, it's clear that the output, that is the serial output, will be taken from the from Q4, that is output of the fourth D flip flop. Okay, that I mentioned, but it's clear. Okay, the output will be taken from, input will be given to, in the previous case if it was D, input is given to D1 of FF1, but output is taken from, shift operation takes place in between, but output or the shifted, the final output or the value previously stored in F4, the output will be given at Q4. Okay, and this is about J1, JK and what we call the SR flip flop. Please go. This is a 4-bit serial in serial out shift left shift register, which means data should be shifted leftwards. Okay, so what I have learned in the case of right shift, that the exact reverse case happens here. Okay, the clock is given from this part. We have D1 Q1 D2 Q2 D3 Q3 D4 Q4. Serial input data is given in here, and the serial output is taken from the Q4 output. That is, we get the output from Q4 of the fourth flip flop. So if you want, we can write here FF1, FF2, FF3, FF4 if you want. Okay, but if someone asks you a question, okay, we need to, there is no chance for such a question, but if someone asks you a question, draw or construct such a shift register, but you need to give the that is, we need to construct a left shift register, but the clock should be given from left, and also the position should be in the case of right shift register, we went from D1 D2 D3 D4, right? We need to give the reverse. We gave the reverse here, D1 Q1 D2 Q2 D3 Q3 D4 Q4. So this position should be maintained as such, but the clock should be given in this case here likewise. Sorry, how can we construct this kind of case? Okay, what we need to do is look at this figure. Okay, and what is the specialty where we give the serial input in D1, right? So we write a D1 here. Let me check. Yes, and we mark here input D1. Output Q1 is fed to D2, right? So output Q1 is taken, and this is fed to D2. Then Q2 is fed to D3. Q2 is taken and it is fed to D3. Q3 is taken, fed to Q3 is taken and fed to D4. And from Q4 we take the output, right? So we mark here as output. You got it? So this is the clock. This is the input. This is output. Please.